In this recording, I'll be working with the VMD software to run this DCD file of the GLUT3 molecule. You can see it's 69 gig along with its PSF, 18 megabytes. Those were loaded, DCD first and the PSF second. I had to load them at a setting of stride of 75. Otherwise there was too much data and the software crashes, so that's the amount of information that's represented. This video is specifically looking at the water and a couple of the transmembrane spanning helices, as we'll see from this article. Molecular basis of ligand recognition transporter glucose. So it's the crystal structures that were posted from this study by this group are the ones that we have used for the simulation. And we go here to page 4, sorry. And starting here, 7 water molecules were identified within the N-terminal domain of the GLUT3 structures. So the N-terminal domain are the first 6 helices. So we'll see that I have those represented only as new cartoon in the VMD. And what we want to watch for is a continuous strip of hydrogen bonds connecting the water molecules and the polar residues of TM1 and 4 that extend throughout the core of the domain. So what we're going to see in the simulation is a lot more than 7 water molecules, and it's repopulated a few times. As we go through the whole recording, you'll see this. I've got the protein as a representation with the residues for those 6 chains, 11 to 32 and 119 to I'm sorry, for just the 1 and 7 domains the TMs that was noted there, and then all of the waters. And we're seeing the hydrogen bonds being formed with those. Then in the new cartoon is just the first 6 helices, TMs. And then in CPK, we have different sets of water, but I'm showing all the water as CPK, so these two won't stand out as being any different, but these are 2 frames in which I had identified the waters that were in the channel. And it's kind of tricky, as you'll see, because many different waters repopulate it. But anyway, and then I'm showing the glucose with surface, and then the residues on these same TMs up here as licorice, so we can try to observe any hydrogen bonds with them. So here you can see the hydrogen bonds as these dash marks. There'll be red and blue ones, maybe some white ones that we won't see. But anyway, I'll begin this now. Let me take it back to frame 1. And I'll just let this go on through and try to comment as we go. So you can see there's a lot of water already in the outside. Remember, this is the occluded outward. So outward is up. That would be outside the cell, and inside the cell is here at the bottom. We're going to see the glucose as a sphere appear up here and move on through. We're watching these residues on these first 6 helices, in particular, anything on these here, to see if they are forming hydrogen bonds with the water. Do I have them on there? Oh, it's 1 and 7. I don't have 7 showing, do I? We should try to change that. Anyway, I'm not going to do it now during the recording. But let's just go through it and we'll see what happens here. So watch the water going through. The other 6 helices would be over here. So I should have that set, and I just need to switch the numbers. Come back to graphical representations. just need, so is the licorice, I'm showing the first 6, but actually what I need are the ones I have in new cartoon, so I can just copy this, Control C on my keyboard, go here, and Control V, hit enter. Now when we come back, we should see all the residues on the ones that we need to see. Okay, let's see what happens. So what we're tracking for is what was predicted, polar amino acid residues on these would be the 1 and the 7. Maybe 1's back there and this is the 7. I don't know. 7 is supposed to be, was it 7? 1 and 4, sorry, 1 and 4. Anyway, let's see what we can observe as we watch the video now. So soon the glucose as a sphere will appear up here. And are we able to see any hydrogen bonds between the residues and the water? Here comes the, I guess I did a surface on the water, I forgot. And it's identified by name, so red is oxygen, whatever, gray would be the hydrogens, I guess. So we're not seeing the carbons with the surface. In watching this, where this is licorice, I've seen that the water forms hydrogen bonds with the glucose as well. But right now we're just trying to see if we're getting waters forming hydrogen bonds with any of the polar molecules. They're also referred to a slippery surface. Supposedly some of the aromatics create a slippery surface for the glucose to slide through. Definitely a lot of hydrogen bonding among the water molecules. Have to, that's where I've been trying to find the numbers of these water molecules out of all the ones that are there. You see there are thousands and thousands of them. If I can find just those, I can put those numbers in, and then I can wow, doing weird things to me here. Okay. You can go here to File, and you can save coordinates. And in this, you can put in the frame here, and then pick, choose the one that would have all those waters, and it'll save just those molecules. Then we can examine those later. So there's a way of exporting just a selected frame, and it's whatever you've selected as a representation. VMD is a very powerful tool. Okay, are we seeing any hydrogen bonds? A lot of rings in there. Might have seen a jump. There's a few jumps where it changes orientation. That's one. Not seeing it. No water's around it yet. So soon water's going to shoot up from the cytoplasmic side and fill the space. But with that first jump, we kind of get a close view here of the waters. It's definitely water that tends to be around the glucose molecule itself. Looks like this is forming every now and then. Oh, get another jump there. And it'll be faint from here on in. But what we're watching now, you'll see water come up in. Let's see if I can zoom in a little bit. But it stays faint. I'd have to rotate it around. I don't want to switch perspectives because it comes back to us in a while. But soon we'll see the water starting to come in from above there. If I go back, you can see it a little bit better. It's farther away, but at least it darkens a little bit. So some water seems to be migrating up from the cytoplasmic side. We're getting more of a column of water. A lot more than 7 water molecules in here at any one point in time, though. So this is the challenge of working with crystals. They may not capture or be able to extract enough data from the X-rays results they get on the crystal to resolve every atom and every molecule that they have in there. So they're limited, plus they are a freeze frame. It's only one state of all the molecules that are in there. With each jump here, from frame to frame, of course it's slow because of so many molecules and I'm recording at the same time, but we still, of all the data, we only have 75% of it, right? So each frame is representing several picoseconds, short periods of time. I'm not sure how long the full run is. It's probably more than 10 nanoseconds total. Now we see we're really close to the point where the glucose is going to exit, and we're seeing solid column of water all the way through, really in the second half. We're at frame 507, and the next jump should have happened there. Yeah, it did. We're closer now. And then at 614, frame 614, there should be another jump. So I guess it was just a jump when I looked away. But now we're seeing the glucose is entering the water, just about ready to be expelled from the transporter. The C-terminal domain, the C domain, the other 6 are involved in forming most of the hydrogen bonds to move glucose through and then to eject it. And that will be another video where we'll exclude the water and just have other things like that so we can watch just those residues. Another video I'll set up will have just the TM7 and 10. There was the final jump. TM7 and 10. So now we can just watch more of the water molecules forming a solid column throughout. And at least hydrogen bonds with themselves can't really resolve. You can kind of see water. Oh, there's an example there with a side chain, right? Is that with water or is that with another residue? I think it's with another residue. But I'll have another video that'll show just the residues forming the hydrogen bonds, just the glucose and licorice, and just the TMs. There's a lot of wiggle in that TM there. And then we'll just take it from there. So glucose is now shot off into the cytoplasm, and we just see all of the water filling the entire chamber. And 7:31, we are done. Okay.